to kind of start SatSure and what market gap that you saw in this processing and AI space that got you interested altogether in this space.
So interestingly, my background is neither in satellite remote sensing nor in AI. I'm an aerospace engineer, and what I saw from my perspective while I was working in ISRO, that the satellite platforms were getting smaller. You could pack in so much of compute power and very good imaging, which was primarily available off the shelf technology because of the advancements in, I would say, cellular technology. Now, that led to the CubeSats, NanoSats, MicroSats kind of disruption within the satellite industry, and hence it became easier for companies to build and launch faster and create more variety of data sets and not just volume. Volume was obviously increasing. Now, what happens is when you have uh, such kind of power to image the earth on a daily or even more than once a day in different bands of electromagnetic spectrum, you are observing so much of changes at a planetary scale, while the changes could be even pointed out to a small object on earth. This kind of fascinated me because essentially it was like of a digital earth, a digital living earth was there, uh, only if we could interpret all of this information and understand how our land and water systems are changing. I mean, I basically from earth, when you're observing land and water. Within land, you are observing man-made structures or natural vegetation. Natural vegetations could be crops, it could be plantations, it could be forest. Man-made structures could be road buildings. Now imagine being able to collect the data of each and every aspect of your life on Earth. I think that's what fascinated me. But obviously, it was a very far-fetched dream, because that kind of data and the ability to infer correctly what's happening required a lot of things to come together. So yeah, that was the beginning of SatSure. We started with what was easily available open source data from Copernicus program Sentinel-2 and Sentinel-1, and first worked out certain models and problems in the agriculture space. And today we have expanded our realm of work across different kinds of industries. I'll pause here. Happy to answer any follow-up question on this.
Yeah, yeah, I think that sounds amazing, and I'm glad that even as aerospace engineers, you kind of caught on to this. because one of the key things that I think I have always heard about is, AI, and that's kind of been the talk of the town in the last at least 5 to 10 years in the space industry. So, when did kind of AI become relevant to satellite imagery? And how has that been, let's say, one of the things that you tried, because you told us you got large data sets from open source places, but then obviously it is about how you processed it that truly probably made what journey so far.
Yeah. So, I'll give an example of uh, why AI was important. Of course, I spoke about this huge volume and variety and velocity also of data. So, all the three characteristics of big data is what satellite imagery anyway fits. Uh, but see, what happens is to make the to infer uh, what am I looking at, are we looking at the right things? Vegetation could be a crop, it could be a fallow land, it could be even plantation. Something like we are looking at a man-made object could be a metal road, it could be a kacha road, and hence it was very difficult to to go through the entire stages of data analysis without using AI. When I say all the stages, like starting from pre-processing, how do you get all of the satellite images prepared and ready for analysis? There are quite a few steps that are required, and there that was the first thing, like augmentation of the data in the pre-processing step. Then comes labeling. So for us to be able to infer correctly, we need to also teach the models with some labeled data. But with so much amount of data, how do you do that labeling without having a huge army of people? And these are labeling feature by feature, right? And there is enormous diversity of objects and landscapes that are visible from orbit. Obviously, that requires enormous amount of label data. So CV models, for example, became very popular to generate that kind of label data set and create those annotations. Then comes model training. So when you're doing model training, then also you need AI to actually do the inference on and scaling based on the data labels and essentially the kind of model you are using to infer. So things like deep learning, transformers, even GANs, generative adversarial networks, they became quite transformational in the way the modeling and inferring from from these images was possible. So yeah, AI has been a game changer, I would say, in the satellite image analysis domain, and I think for folks who are from the GIS and remote sensing industry, a good parallel could be OSM, OpenStreetMaps, where there was base imagery available. There were volunteers who would edit and add the features. But with for them to scale this, it became a big problem, and they had to essentially start using certain like for example, Meta's feature detect algo. When that was released, it became an integral part of the web editor there, and hence the scaling even in maps happened because of AI. So satellite imagery is one of the things that AI has touched and transformed, I would say.
Yeah, yeah, totally. But just before we continue, I would like to welcome all our listeners. I want to say thank you for joining us. We are in the 10th edition of our XSpace with Prateep Basu, CEO of SatSure. And today we are going to be discussing about AI-powered insights on satellite imagery. So, as we continue the topic, Prateep, I wanted to ask, there is a growing interest in edge computing. Like, I think even you were talking about this idea of, more compute, and the satellites are getting small. And, so how does this AI, I'm not sure how SatSure is, going there yet, But edge computing has become a very important thing, like upstream processing of this data at the satellite level before it is, transmitted down to Earth. How does that compare to, downstream processing here? Once you said, we got GBs of data down and then we started processing it. So what are these trade-offs of, trying to compute on board the satellite versus down here? And can you give us any insights on what is the approach SatSure has thought of in this case?
So running AI models on board satellites is essentially to offer faster real-time processing for immediate image analysis. And yet it is limited by the restricted computing power today, and obviously the energy constraints as compared to a cloud-based processing on ground, uh, from where you would get much greater flexibility and scalability, and obviously access to more powerful computing resources. So what people trade off against is primarily latency. Latency meaning that what are those kind of time critical application where you really need to respond fast. So it can be events like disasters, like autonomous vehicle, for example, and in also situations where you have limited bandwidth, where transmitting large volumes of raw data to the ground is not feasible. So yeah, that's where a edge computing on satellites kind of clicks. But as I said, there is a lot of difference in terms of how the optimized model, how optimization of the models have to be done, and it is definitely a bit of stretch on the hardware to accommodate edge computing. We had that as a part of our system design because we truly believe that there will always be these kind of time critical and limited bandwidth kind of app application and mission modes where edge computing will have the advantage over the traditional computing, but it need not be an overkill to do everything.
Yeah, definitely. So, just before we move on to the next section, which is totally about the application layer that you're so, strongly in as Sure, I wanted to ask, in your opinion, maybe in the last 2, 3 decades, what do you think were the key technical breakthroughs that has probably made this kind of AI-driven satellite analytics possible,
Mhm.
right? What has been those key breakthroughs that you see that made this possible today?
See, the biggest technical breakthroughs that have made AI a necessity almost in satellite image analysis includes the development of deep learning algorithms, particularly CNNs, which is convolutional neural networks, which can automatically learn complex features from large volumes of satellite imagery. And that allows for highly accurate object detection, classification, without needing extensive manual feature engineering. And this is a very important aspect of difference between machine learning and traditional machine learning and AI, because what happens is traditional machine learning is that you go with this kind of extensive feature engineering, and more often than not you overfit the model, which means that your model scalability is gets limited. So if something that you have built for maybe a very small neighborhood or a region in India, even some part of India may not work in another part of India with the same performance. So that is where that is one of the biggest, I would say, impacts also of AI. But r- more to see about what were some of those breakthroughs. I mentioned about CNNs, so let me go a bit deeper into it. So deep learning and CNNs excel at identifying patterns in complex visual data like satellite imagery. So that is enabling the precise detection of different features, like I mentioned, it can be forest, roads, buildings, etc., change in land cover. But it also requires a lot of processing power. So this is the other industry trend that made AI kind of an integral part of the industry. That the amount of compute power and parallelization of it on just totally enable deployment of AI models on the cloud. Otherwise, just to run it on your hardware would have been impossible to do. And because of that, now you can analyze vast amount of data very efficiently. And that's not just in inference, but also I would say the training became a lot uh, easier. And it's not just the process, but the costs have also come down significantly. The cost of training a model to that of inferring has been dropping like significantly every year. And um, all of these have made those feature extraction or automation of the feature extraction much simpler. It has improved the accuracy, especially for tasks like land cover classification, change detection, object detection, and the complexity of the analysis that you can now take, especially with satellite imagery, including fusing different images with variations in lighting. It could be two different images, like a SAR, a synthetic aperture radar, was with a multi spectral and optical, with different weather conditions in which images were taken. All of these kind of complex data fusion also gets much easier because of the advancements in both your deep learning as well as computing. So yeah, I guess that's some of the stuff that I can think of.
Awesome. And I think there have been key and kind of machine vision breakthroughs that I think has changed the entire industry, like not just space, but overall, even on Earth, I see a lot more of those applications coming through. And
Mhm.
let's segue into the application layer. So I think this is where SatSure is best known for, and the analytics truly come to mind. So let me just start with asking you, in general, what are some amazing case studies that SatSure has kind of brought about in terms of which industry, which domains you guys work in? Because I can be very specific, but I think you can bring that specificity even better. So, just introduce SatSure a bit more to us, what domains you apply satellite data analytics to, and yeah, just give us a bit of an introduction to the company. That would be great.
Sure. So, see, we have worked across so many domains. We have productized our offerings in a few, and continue to deliver solutions in others. So I'll give an example. Earlier, I was mentioning about the ability to infer about different types of vegetation. Now, just identifying if it's a cropland or a forest land, that's not, I would say, a big challenge anymore today. But to go to crop type, identifying what's the production potential, what's the stage of the crop, all of these different indicators, where the capabilities that we build over time, where we transition from initial machine learning techniques like SVM, random forest, etc., to more deep learning approach, and we're able to do, in get like do analysis of entire India at a parcel by parcel level within like every week, once in every week. So that is a scale we reached. Then as these capabilities got built, we kind of saw what all problems can we solve. While there was the obvious thing of providing advisory to governments and farmers, we chose to take up a structural problem, which was financial inclusion of smallholder farmers. Now, this is one part, agriculture financing, that has been very broken. Now people like us, we have credit scores. Now we don't even have to go to a bank. We keep getting offers on our WhatsApp and calls about some personal loan or home loan, right? But that's not what happens with farmers. uh, they have to produce the ownership documentation of the land. Someone has to go and check and verify that land, obviously along with the KYC documents, and then use their best judgment, because the bankers may not actually come from agriculture background. They will use judgment only to understand how uh, th- how this farmer is in terms of his practices, whether he can trust him to say that he's growing the crop or which is taking a loan. So it was a very broken journey. It used to take like 15 to 45 days to get a small ticket loan, like even a couple of lakhs, right? And that's something which seemed like very ripe for disruption. And with the capabilities that we had built, ability to infer so much from satellite images about the crops, its production, the water cycles, irrigation, etc. We package that as a kind of a, let's say, alternative credit score to banks deeply with them, to the extent that today, if you go and Google and see RBI is enabling 10-minute loans, 30-minute loans to farmers, that entire journey, which was a physical journey for a farmer and for a bank, has become a digital journey, like from 15-45 days to a few minutes, is what we kind of enabled the banks to come to, just because we were able to build this capability and integrate it with the land record information alongside the entire workflows of how a loan management systems work. So yeah, finally your capabilities in AI, your capabilities in satellite image processing, handling, management, whatever, has to go into solving some big problems. So this is one of the big problems that we are solving today.
Wow. I mean, they say farmers are the backbone of the nation, but you're building the backbone of that backbone. Because I think that capital that farmers need is so critical, and you have solved such an amazing problem, Pradeep. I really appreciate the mission you guys are taking on. And yeah, I'm happy that India is getting such amazing digital infrastructure. So, with that, like, can you give us a bit more on the idea of, how the satellites and imagery can maybe even help farmers further, maybe in crop monitoring or crop insurance or, growing food according to the seasons and things like that. So, if you have a bit more of insights on that, that would also be helpful.
Yes, absolutely. So, see, from the very beginning, we were not very sure that whether a direct channel to farmer, based on the kind of tech we developed, would be a good idea. But thankfully, the government has acted as a very good intermediary between tech companies like us and the farmers. So, one of the key initiatives that the government has backed and built is called AgriStack. In that AgriStack, it's a combination of farmer info, farm info, land info, all of that, going into one single database with a consent framework around it as to how the data exchange between the farmer and others happen. So we are one of the key implementers of AgriStack. We have been working with the UP government, for example, and the different ways in which advisories are provided, because the farmers will always trust information that is coming from. It is difficult for them to build that trust with private companies, especially startups, where they may not even be seeing the people's faces. So the government has not only used our data for providing them advisories on irrigation, like when to water, and weather advisories, etc., but also help the farmers with contingency plans. For example, if the rainfall has been lesser than usual for the first, let's say, 15 to 30 days, then what are the second or third potential crops which would be the best for the farmers? Those kind of advisories have gone. Similarly, information about the direct benefit transfer based on the farming activity, based on the um, also the retailer information, all of that combined is used to credit the amounts to farmers' accounts directly. Similarly, when insurance claims happen, some natural event happened like drought or flood, and money has to be given to farmers. Now the process has become very streamlined with the use of satellite imagery as a way to verify the claims and process the farmer insurance claims within 30 to 60 days. Earlier it used to take like 9 to 12 months. So yeah, these are some of the different ways in which the data and AI capabilities are being used to reach to farmers to improve their livelihoods and their overall information of how to apply it for improved productivity and yeah, better touch points with their ecosystem.
Yeah, it's absolutely fascinating, Pradeep. I mean, satellite is truly touching lives beyond anything we can think of, and it's amazing. So one of the things that before we go into the next question is I want to talk to the audience and say I thank you all for taking time out of your Saturday nights to join us here with Zetagravit. This is our 10th edition of the X Space, where we have our esteemed guest Prateep Basu, CEO and co-founder of SatSure. And I would also like you guys to check out this Zetagravit website where we write blogs, we provide launch updates, and a lot of other things related to space. So I really want to thank you all for joining us today. And please stay tuned till the end because we have a Q&A session. Or if you cannot stay till the end, please leave your questions in the YouTube stream or in the comments of the space below so we can ask Prateep and you can check on it later. So I want to thank all the listeners and yeah, feel free to share this space and get more listeners in. Thanks a lot. So yeah, Prateep, getting back to the topic, I think you touched on a very important thing that I was going to touch on next, which is natural disasters, right? So I think insurance is just one side, but how does Earth observation typically help with disaster response, right? I think decision makers have a lot of things in their minds when a natural disaster is about to strike or is striking or has just passed. So, in your experience, how does, both satellite imagery and this idea of, how AI in satellite imagery has kind of changed the game in terms of making decisions and providing decision makers with better awareness on how to respond? So, yeah.
So I'll give you a live or real examples where our data has been used for response. Usually, when something like this happens, we also work on a voluntary basis. So last year, there were massive floods in Vijayawada and the region in Andhra there, and there were a lot of families who were stranded, who couldn't, go, who were basically running out of food. So at that time, it was very important to do the food aid and rescue kind of operations on ground. And well, AP being one of the tech savvy states, they had a fleet of drones to carry these as packages and drop. But they still had limited number of drones, and there were so many people affected. So for them, it became important to prioritize at where uh, which are the top areas where we have to go now, and how do we manage with our limited set of people and machinery to essentially drop, let's say, food packets and help people. And for that, the first and foremost thing was we did for, was that there's something called synthetic aperture radar. Now, when you have this kind of flood situation, cyclones, etc., you have a lot of clouds and optical and multispectral satellites, which are the ones like in visual. Also, you can see those Google, like for example, maps. Those cannot get any information due to the attenuation from cloud. So that is where synthetic aperture radar becomes a way of data collection because it operates in the microwave part of the spectrum. So the good thing is with there is a satellite called Sentinel 1A, B. These are like a series of satellites which are open source such SAR data, and that also at 10-meter spatial resolution, which is pretty decent for any kind of large area analysis. So we could essentially use the ready data coming from this kind of satellite to identify the areas that are flooded, because water has a very different response than any other land feature. It's called something called as backscattering, and that helps to identify the flooded areas. So this data became the de facto information for identifying the most flooded areas in terms of extent of flooding and depth of flooding, so that the drones with the food packages could first go to these places. This operation ran for a week, and more than about 20,000 people apparently like got support.
Wow, wow, that's amazing. And I think it's great that you have taken up such voluntary initiatives. And you know, I definitely see a lot of, multispectral and hyperspectral solutions coming to India. So I just wanted to know, like, how SatSure will be looking to maybe procure imagery and maybe create more layers of information. So do you look at just indigenous suppliers? Do you look at global suppliers? Do you look at only open data sets? How will this go ahead? Because I think you've touched upon that a lot.
So, for any kind of analysis on natural resources like agriculture, forestry, we mostly work with open data. Today, you have a lot of this open data sets, whether it is resource sat for of ISRO, or Sentinels in Europe, or Landsat. So there's a plethora of that open source data. However, not all kind of feature detection can be done using such data sets. So for that purpose, like high resolution satellite images, we source those images currently from companies like Airbus, Maxar, Planet, which are all foreign companies. And this is one of the key reasons where, because we don't own that data set, so we are also limited by how much we are able to do. That led us to start working on our own fleet of high resolution data, which is called Collide. We established a subsidiary just to do this work, where so that we become a vertically integrated firm which derives intelligence from Earth observation data.
Yeah, I think you're also the CEO of this Kiradio subsidiary as well, if I'm not wrong, right?
Yes, it's a 100% subsidiary of SatSure.
Yeah, that's amazing, and I think it's the right step for you guys. Having to generate your own imagery and maybe operating on your own constellations. It's really amazing to see where the Indian space ecosystem is headed. And one of the things with Kaleido, I'm not sure how SatSure is maybe dealing with this, but maybe you have some insights on the space situational awareness, right? So, uh, how does this kind of move forward with maybe something like debris tracking, or something that is much more out there in space? Because even satellites have their own potential disasters waiting to happen. So, is SatSure in that space? What are your thoughts on how AI-powered satellites can do something with related to debris and asteroids and things like that? Pradeep, you are not audible uh, to us. Can you just give us a thumbs up if you can hear us? Okay. Can the audience give us a thumbs up if they can hear Pradeep?
No?
Yeah.
Hello?
Okay. Yes, Pradeep. Yeah, you're back. Sorry for that disruption. But yeah, I'll have to ask you to restart the answer. We were not able to hear you for a little bit. So yeah, please go ahead.
Okay, okay. Am I audible now?
Yeah, you are audible, perfectly audible.
Okay. So I
Thanks.
was just highlighting about a company called Digantara, space situational awareness work. They are doing some really cool stuff. And we are not into space situational awareness. Although we do strongly believe that this is something which the industry needs. There is today way too much traffic up in low Earth orbit, especially with the Starlink satellites, and the risks of the orbit maintenance and collision especially is quite high. And it's not just because of other satellites, it's because of the tens of thousands of objects from defunct satellites and launch vehicles, etc., that are also you know sometimes part of that entire set of debris. um, there is also a lot of work on AI, especially for situational awareness, because you are essentially again collecting data, whether you are collecting it from ground-based radar tracking the debris objects, or you are doing space-based image capture like Digantara is doing. So in both the approaches, you need you're literally looking at uh, so many different orbital parameters associated with each and every object, and hence AI has a very strong role to help in doing path propagation, collision avoidance, and maneuver trigger kind of algorithms.
Yeah, very true. And yeah, I have met the Digantara team at the last year's Space Expo. In fact, I met even SatSure at the last year's Bengaluru Space Expo. So it's always amazing to see, what new things are coming up. And I'm glad you gave them a shout out. It's really awesome to see where the space ecosystem is kind of going, and how far along India is in terms of developing the technology and the capabilities. So, along with building anything, I think we always face challenges and setbacks. So, I want to get into some of the challenges here, but before that, let me just address the audience again. And I want to really thank everyone who stayed along for the journey. This is the 10th edition of Zetagravit Space, and I really appreciate all of you for sticking around, even those on YouTube. So please do check out Zetagravit. We write blogs. We are a website that is trying to be everything space. So we try to provide a lot of different things. And I would love for you to give your thoughts on Zetagravit down in the comments below. So if that is your thing, please do also reach out and DM us if you have anything to contribute to us. So with that, let's get back to the space. So Prateep, can you give us some idea on what have been the biggest challenges in this journey, right? In making the prototypes, in scaling up the intelligence, technical challenges, maybe some regulatory challenges. Give us a bit of an overview, because maybe our audience is a bit more widespread, so we can't. I don't think a lot of the specifics would be useful, but yeah, I would love to hear what challenges you've faced so far.
Yeah, sure. I think this will be a long answer because you have asked technical and commercial challenges together. So let me cover the technical challenges first. See, we are dealing with a large amount of data, and satellite image data sets require high processing and storage capabilities. I think initially when we started and we were bootstrapped, being able to afford huge cloud bills was quite stressful. And I think it was good that AWS used to, and not just AWS, AWS, GCP, all the cloud service providers used to provide good amount of credits in the early phases while you are doing the development, optimizing your like your architecture here. So this was one of the first challenges that we faced, like huge amount of data. Second was variable image quality. Now, see, a number of variables like atmospheric disturbances, sensor noise, and the satellite distance from the Earth can lead to inconsistent image quality. And these variations in image resolutions also happen, and all of these require a bit of additional processing, pre-processing as we call it, before the real modeling can be done. So this was another issue, especially because we were working with open source data that was opened up just a year before we started. So the community support for it was still building up. Today it is quite good. Earlier, things were all like evolving. So we feel that while we may have started in India, our journey very much linked to all other companies who are in this domain, who have contributed a lot to different open source algorithms and libraries to take care of these challenges. Then came the lack of labeled data sets. Now, I spoke about agriculture quite a bit, so I'll take that example itself. Uh, if you don't know the ground information, we call it ground truth, that what you are seeing is from an image is a rice or a wheat or a mustard or whatever soya bean field, then you can never build a high accuracy model, and you don't have such kind of labeled data sets available in most parts of the world, including India. US had some, and that's why most of the research in this domain of satellite imagery and AI was done in the US, and also the contribution, open contribution also kept happening in that same place. So this was a very big challenge, and we had to linearly grow our database of ground truth so that we can train our models better. Then there are some other, I would say, operational challenges on the technical side, like periodic changes. It can be human activity, even and the seasonal vegetation, understanding of all of that. Like, for example, seasons. If you are tracking trees, so eucalyptus tree cycle would be very different than some other tree like date palm or something. So if you're doing analysis, you need to also have the context of that value chain here. And finally, I would say scale variations are also very important to take care of. Like depending on the altitude of the satellite and the angle at which the imagery is taken, appear at different scales. Now, we don't face that problem with vegetation monitoring because what we get mostly all of the imagery as nadir viewing. Nadir means you are essentially vertically above that point that you are observing. But then there are images, especially high resolution images that are taken off nadir. So you can see, let's say, some amount of depth features in the image. And when you start having imagery at different off nadir angles, this kind of issues come up. Building could take up a few pixels in one picture, in one satellite image, and a large portion of another. So these are challenges that kind of obstruct you to identify small objects, even if the satellite has the or the satellite image has the context in it. I gave a very long answer on the technical side. Should I pause and then maybe take some follow-up question on those before I go to commercial challenges?
No, I mean, I know that the whole challenge is coming together, right? Like I think the technical challenges require a lot of commercial capability, and so I'm pretty sure they are kind of intertwined a bit. So I would ask you to go on and probably provide all the context, because I think that is where it is truly helpful for us as India, because understanding technology is one thing, but also scaling up that commercially is the other challenge that I think India is currently trying to do. So I would appreciate it if you just continue. Yeah, thanks a lot.
Okay. So, see, everything I mentioned on the technical challenges, and this was all on just the data handling, and then there is models, and models are essentially uh, giving you some probabilistic output. These are not deterministic like software, and therein lies the linked challenge to commercialization, meaning that when you are looking at uh, uh, catering to a customer, building a certain use case, it becomes very difficult to get the customer confidence initially unless you have solved all of these challenges, because of all the technical challenges that I just highlighted. Now it is not uncommon to hence see that algorithms are not scaling, which means that dealing with a customer, they're not sure whether we would be able to serve them across their entire portfolio. And hence, there will be a lot of these POCs after POC, proof of concepts. Then For example, there are many data, the traditional ML approaches, they do not scale very easily, like the ANNs and random forest, etc., because they are brittle trained for a single situation and then inaccurate elsewhere. So to generate a new solution, you have to retrain or rebuild the algorithm, which means that there is another, like a huge amount of time that further goes to build a set of training images and categorizing them accurately for another region for the same customer. So your go-to market velocity is also obstructed. And While I'm speaking of more outward facing metrics, in order to do all of this repeatably with the right kind of precision, the right kind of recall in your algorithm, and to do this data engineering and data management again with a lot of reliability, it requires a very highly skilled and expensive labor force. Uh, Otherwise, you are continuously in this trough of disillusionment with the customer. And All of this means that this such kind of business will be a high cost business to both the entrepreneurs as well as the end users at the initial front, before it starts actually creating the value for the end customer. And by the time it does, the earlier models where we were kind of uh, I would say fenced to machine learning techniques, it led to this high cost at the entrepreneur's end, translating into high price for the customers, which would again lead to friction in adoption. And this is one part which no one speaks about: how AI and the ecosystem around the AI is actually creating a much faster GTM for satellite image analysis and the applications around it. And this is, I think, one very interesting trend that we ourselves have gone through.
Yeah, yeah, totally. And I think one of the biggest challenges that I've heard of many applications of satellite imagery, falling apart was the commercial endeavors were just too expensive. So it's amazing to kind of hear that, AI is empowering as well as democratizing this access to imagery as well as giving us, much more with much less. So, with that, I think we will head a bit more into a deeper topic for me, which is what are your thoughts on the ethical challenges behind this kind of space-based observation and surveillance? Because uh, ethics is kind of a little bit of a close to my heart. So I would like to maybe hear your thoughts on the ethical side of this kind of operation and what do you see?
Most ethical issues, AI surveillance using they include like privacy invasion, algorithmic bias, and accountability. Uh, Now, These challenges definitely underscore a need for a balanced approach that respects the individual and sovereign rights while achieving the commercial objectives. Whether we like it or not, Earth observation is a dual-use technology. Once it's in orbit, it is not in, uh, it's not someone's sovereign property that they can say that you cannot image over my country here. Uh, and yet it is so useful for the entire humanity to be able to solve for the big problems, building more climate resiliency in our systems, financial inclusion, sustainability, etc. So somewhere we have to balance out the ethical concerns, I feel. And Especially when it comes to what kind of general frameworks we have. For example, the GDPR, the Data Protection Regulation in Europe, right? Uh, it has already extended its applicability to AI-driven surveillance. So one can assume that as the proliferation of Earth imaging satellites and solutions using AI on it happens, within the framework like GDPR and India's data privacy, framework as well, we would see the ways to kind of uh, also address some of the concerns on Earth observation, much lesser than video surveillance and face recognition and all that, because whatever you do, you cannot go and identify a person from satellite image. You may be able to identify a person's income potentially, and that is a different kind of ethical concern than identifying someone privately. But yeah, those are my thoughts.
Yeah, definitely. And just to kind of let the audience know why this topic came to be was because Nitin Gadkari sir has been talking about satellite-based tracking and kind of collecting toll. So that was one of my main things. Like, is that kind of how much tracking from satellites can we as a society bear, and how much is the trade-off with the kind of wonderful things that come from Earth observation. So that was a wonderful answer. With this, we'll get a little bit more into the future of this segment, and I think Parth will take care of some of these questions. So yeah, thank you all for listening in and tuning in. We are at the roundabout of an hour, so I want to thank you all for coming to the 10th edition of the X Space. Do check out our website, zetagravit.in, and I would also urge you guys to read our blogs, stay up to date with space news, and I would really appreciate it if you could all just repost this space on your timeline. It would be a real big help. And yeah, don't forget to follow Zetagravit. That is the most important thing. So you can keep in touch with us as we bring more amazing guests like Prateep sir here. So thank you all for
Yeah, thank you, Prateep. Thank you, Phantom. So, wait, I guess there's some technical issue. Prateep is not connected.
Yeah, Pradeep can just come back on as a speaker, and we will just get restarted with the question once he's back up. So I appreciate your patience as we navigate this technical difficulty.
Guys, let's wait for 5 minutes until he rejoins. Then we'll continue our space. Thank you for being with Zetagravit. If you have any speaker suggestion, then do let us know in comments below. Yeah, hello Prateep, can you hear me?
Yeah, I'm sorry. by mistake I had switched over to official account. So,
Yeah, no issues. Okay, so like before getting into the next question, I have this idea. Like, every technology has that discovery of wheel movement. For industries, that was industrial revolution.
mhm.
For AI, I believe it was probably the launch of GPT-3. So what do you think? What breakthroughs do you foresee in next 5 to 10 years for AI-powered satellite analytics?
Well, it's it's become difficult to predict AI because it's not really following Moore's law. So, to be honest, there is a lot of work that's required on the large observation slash vision models, which makes uh, you know inferring the huge quantity of information available through satellite images possible. I think the one big uh, driver that would happen for AI, I cannot say within AI, but for AI, would be the advancements in quantum computing. I think that would be a game changer, just because uh, the kind of computing power that you keep that will keep increasing would be extremely high. And while we are every year seeing that change exponentially, but I think quantum computing would be a big disruptor for AI, especially in the Earth observation.
Yeah, that's true. Like the point is very valid because to predict the next move of AI, we need to consider our hardware and software capabilities. So let's see what all amazing things are there for us. Okay, so my next question would be based on little bit astronomy side. So recently PRL discovered exoplanet. So I was wondering, like, could AI help us explore other planets, and what are some cool future possibility for AI in space?
Well, look, astrophysics, the study of also planetary systems, etc., they have been using pattern recognition for a long time, and the volume of data is also quite high, to be honest. Uh, and yes, the answer to your question is a yes. It has a lot of potential for helping find new planets as well. Especially now that we have a much more powerful telescope doing that, right? I mean, we had we have the James Webb Telescope, which is collecting all of this data in so much clarity. So, just like you are observing features on Earth, you can also observe features in space, and of course, AI plays a role there. It's there also. How can it accelerate the development? Only time will say, because the already ever since the James Webb Telescope has been commissioned, already we have the velocity of discoveries have increased significantly, and I'm guessing this trend will further just continue with infusion of more and more AI.
Yeah, I agree. Okay, so since I'm connected with lots of students, and nowadays, since we know how AI popularity has gone on increasing exponentially, so my next question is, how can students and young professionals get involved in AI and space tech? Because many people who are space enthusiasts has took the computer science field just because of AI, and they found AI, ML, and all these new technologies very interesting, but they don't know where both of these combine. So can you guide them on what skills should they focus on?
So, uh, my so it's a difficult question suddenly for me. All the questions on satellite image processing was easy because as a student, when I was a student, I was reading C. So now we are speaking of students and getting involved in AI. Look, I have always found that the best way to learn anything is within communities, and in schools and colleges you have the clubs. I think that's a good starting point. It's a great way for students to make meaningful contribution while also learning about AI within the school or college. Uh, one of the most popular clubs that you will find everywhere in every college is robotics club. And I think as a beginner, students who are interested in AI can explore how robotics utilize AI to find solutions to real world problems. That would be my my suggestion, because most of the work in robotics is essentially perception modeling. It's based on vision here. Two
Yeah,
big components in AI, right?
yeah, that's true. Also now since we are moving towards more like a like multi streams approach, like you don't need only software engineers, you also need embedded engineers, and so that's why like we should focus on multiple streams.
Yeah, absolutely.
Okay, so yeah, so like we don't have any more question. Now we can jump to Q&A round. So like if you have any questions, do drop in Twitter comments or YouTube comments.
Or you can also request to come up and we will bring you up. And I would really appreciate it if you have relevant questions for Prateep sir. We don't want to keep him around for too long. We appreciate all the time he has spent with us here. So if you have any questions, please do come up or drop it in the comments right now. So we will wait for about 2 minutes. And in the meantime, Prateep sir, I would definitely, maybe pick your brain on this, which is the fact that, what do you think is the next breakthrough that you see that truly makes or breaks this industry? Because I think one of the things that I was thinking of was like when you say that compute and power is limited, Starship, which has been growing, in size immensely, means that we can once again start putting out really heavy payloads and really, big satellites out there. So that I think will again change the game in terms of how we observe what we can do out there in space, both in terms of edge computing as well as in terms of observing. So, what are your thoughts, perhaps there? Would be my question as we wait for some of the comments and questions.
Yeah, that's a great question. Indeed, there are a lot of areas where potential breakthroughs are happening and will continue happening. I think one of them is the development of a digital twin Earth. Uh, Now, what's a digital twin here? Um, it's basically comprehensive virtual models that simulate the Earth's complex systems and interactions. Um, i- if we are able to build those with very high degree of accuracy of the prediction, it will help us to test the mitigation strategies and predict mitigation strategies to climate impact, and also be able to predict future environmental impacts. I think that's a big uh, breakthrough for so many different industries. Um, like take agriculture, half a degree increase also in average temperature is resulting in very different plant phenology, different production. It's completely eroding livelihoods of farmers. You take the amount of losses that the industry is facing on critical assets, whether it's power or dams or so many different, like houses, people losing their houses because of very erratic natural calamities, like 1 month's rain in one day, right? What do? Your systems are not designed for it. So it's important to move all of this data and analysis capabilities into simulations that helps us to design our.
Bit with it as a model-based system engineer myself, and I'm always fascinated to see how many layers of information it truly takes to make a digital twin. With that, we have a question from our YouTube stream by Kashyap Bhadra. who says that how can effectively AI help in maybe improving communication to space? So he means to say communication more efficient in terms of hardware. So if you have any insights there, yeah, please go ahead.
So if I understood correctly, how can AI help in communication satellites or communicating with satellites?
Communicating in space, basically. So he means to say that it will take a certain amount of time. So how do you make communication more efficient, say hardware wise? So I'm assuming communicating with entities in space.
Okay. Well, it in terms of AI applications for communication, I think the primary impact would be at the signal processing that is done on board, especially for two different devices very far apart which are communicating, right? And if we don't today, we are in like special. I'll take the context of two objects in space which are communicating with each other. The ability to in analyze when signals velocity and quantum become slightly higher is quite low using the onboard computing, and we have to use a ground station backhaul system. So I think that's where edge computing and AI models to do the signal processing better would have some impact there. But I am not an expert, to be honest, to say exactly how. But at least being from the industry, I can think of one impact.
Yeah, definitely. And I think it was a hard question to answer regardless. It was like a very deep telecommunication technical question. Go ahead.
Yes. So my question is that you said that while we are using CNN to analyze the satellite data, there are chances that it might affect the scalability of it. So can you please elaborate, like how exactly will it affect the scalability?
Yeah, because see what happens is with CNN, uh, the the amount of training data that is required to actually get to a precise um, in set of information generated is higher than, let's say, a DCNN. So architecturally they are slightly, they might be similar, but the primary difference in them, which is where DCNN, they include other types of layers as well, such as pooling layers and fully connected layers, etc., that are not available in CNN, which makes it possible to reach the same level of model performance with a lesser amount of training data. So that's a very big, I would say, accelerator for your go-to market, because you need your model generalization to be high. Otherwise, you are creating more and more region-specific, feature-specific models.
Any follow up to that?
Yeah.
No, no, no. I understood. Thank you so much.
Mm. So yeah, I mean, just to add on to that, look, if you are from the domain, then you would understand that dynamic convolutional layers also use dilated convolutions, right? And they have a larger receptive field than regular convolution. And so this is what allows the layer to extract features from a larger portion of the input, regardless of its size. And this is why the handling of inputs of varying lengths becomes easier in DCNN against a CNN, traditional CNN.
Well, like I haven't studied DCNN and the related topics yet, but I will surely look into it.
Sure, sure. I was just giving an example of CNN scalability by taking the comparison with DCNN because it's just because CNN as it is quite powerful, but not with the kind of data that we are speaking of. That's the reason I took that example.
Yeah, no worries. Thank you so much once again.
Hmm.
Yeah, I think if anyone else has a question, Ayush, do you have any question? Parth?
Yes, yes, I have a question. So there was a recent tweet about black sky deals. So what's your take on that? Like most of the CEOs comment on that, okay, and you also commented on that, okay. So what's your take on that?
Okay. I mean, it was a bit of a vague announcement because it didn't mention clearly who was the end user and also, and the way it was written or reported rather by Space News, that India's first commercial satellite constellation. So yeah, you're referring to a thread between me, Kshitij, and someone else. So,
Yeah, yeah.
Pixel is operating already the first commercial Earth observation constellation. So, what is the point of reporting something else just because it's an American company and Space News is an American, news firm? I think the Western bias continues. That's why we said okay.
As you mentioned, Pixel. So do you see collaborating with them in your future?
We do collaborate with them. We are all part of a very small industry, and we are also early users of their data.
Yeah, thank you.
Great.
So, do we have any more questions? Okay, so before closing remarks, if there's one key takeaway from this discussion, what would you like the audience to remember?
Uh, Key takeaway. Well, one key takeaway that I would like the audience to remember is that AI in satellite Earth observation will create not one but multiple watershed moments in the coming years. So we have to keep a watch out.
Yeah, that's true. Okay, so on the behalf of Team Zetagravit, we extend our heart gratitude to you, sir, for sharing your invaluable insights and inspiring us with your journey in space tech and decision intelligence. Your expertise has truly enriched this session. A big thank to our amazing audience for your enthusiasm and engagement. It's your support that keeps XSpace growing. And of course, a special shout out to our dedicated team for making this event a success. We look forward to seeing you in our next edition of X Space as we continue exploring the wonders of space and technology. Until then, keep questioning, keep exploring, and keep looking up.
Thank you, everyone.
Yeah,
Bye.
thank you.